Welcome to Calibration Discrepancy Process Descriptions. Thank you for your interest. We hope you'll take time after this short presentation to explore the other Triad Unlimited presentations on YouTube, follow us on LinkedIn, and visit our website to see all our service and training offerings. Calibration Discrepancy establishes methods for discrepancy trending, review, notification, and use of reverse traceability. What happens when we find a discrepancy? It depends on where we find it. An out-of-tolerance or OOT finding in a critical instrument is one thing. A finding on a not-so-important instrument is another. What about the MTE device itself being out of tolerance? What about the standard that we use to verify the MTE being out of tolerance? How do we tell our customers about each of those? Calibration discrepancy covers how discrepancies will be identified, reviewed, communicated, and contained. Guess what? There are 4 processes associated with calibration discrepancy. First, there's calibration discrepancy trending, calibration discrepancy review, calibration discrepancy notification, and calibration discrepancy reverse traceability. Here are the benefits related to calibration discrepancy. We have a process for identifying, communicating, and investigating calibration deviation, which allows means for discovering and eradicating underlying causes. Discrepancy review protocols ensure that product impact is evaluated and quality is preserved. Discrepancy communication allows customers to act based on their internal protocols. And reverse traceability serves to maximize containment of potential adverse impact from use of out-of-tolerance standards. Calibration discrepancy trending methodology makes sure there's a process for classifying, trending, and taking action when issues with calibration are discovered. There's an old saying in quality that what is tested is not sold, and what is sold is not tested. The quality of product that is consumed is never tested. Therefore, we must have absolute confidence in our processes, and we get that by building in quality in every process step by controlling every step. When process steps are deviated from, we want that to be a big issue if product quality could be affected. Deviations are GMP mistakes or errors such as making unapproved changes to operating context or process parameters, performing an activity without training, operating outside required process parameters or in-process control limits, and failure to follow procedure or batch record instructions. When deviations happen, they need to be uniformly processed. All deviations should be documented and explained, and critical deviations should be investigated and documented. The idea here is not about getting product released by minimizing or explaining away a deviation. The idea is to produce a plan to correct the immediate problem and then prevent recurrence. In calibration, deviations from approved standards of calibration on critical instruments could have an adverse effect on product fitness for use, which basically means the product cannot be sold. Somebody could have gotten hurt if the product were sold, or other substantial issue. Ideally, there should be no such thing as a planned deviation, but in real life, situations do arise that require evaluation of the effect on product quality. For instance, a long process could prevent access to an instrument with calibration lapsing before the process is completed. In this case, a planned deviation or calibration extension would be initiated. The approval of such a deviation is based on statistical data that shows the calibration history and the drift rate could extend beyond the due date of the instrument with a reasonable risk that it would not fall out of process tolerance, if continued to be used. That said, approved documentation exists for a reason, and that is to make sure we do things correctly. If for some reason a procedure or batch record cannot be complied with, it is never a solid idea to work around without this type of risk evaluation. Habitual or routine planned deviations are almost always a sign of a weak culture of quality. Calibration discrepancy review methodology serves to provide a uniform way to process deviations. This discussion about deviations is limited to how calibration interacts with product quality. When process instrumentation is out of calibration, process parameters such as temperature, pressure, vacuum, or others might operate outside of defined limits. if the condition that causes the instrument to be out of calibration is significant, the affected instrument could allow the associated process parameter to exceed process tolerance values. If this happens, product quality, purity, or strength might be adversely affected. When the calibration program discovers equipment that is out of tolerance, it is very important that the deviation be communicated and evaluated in a timely manner. Needing to have a process is important, as discussed previously, but that process must be structured to contain certain elements. Communication. There must be some time constraints around deviation reporting. There should be rules established in the calibration program that establish the communication path and timing. Usually, a calibration deviation has to be reported to quality within 24 hours to be considered timely communication. Deviation communication should be consistently formatted and have some minimum information requirements. This is the handoff between operations, calibration, and quality. Prioritization. It is important to understand if the out-of-tolerance finding could affect the quality, purity, or strength of the product. If a deviation is critical, it must trigger an investigation. It's a good practice to identify critical instrumentation and include that classification in the instrument asset record in the CMMS or in the calibration software. This can save some time that quality might otherwise spend collecting that information. Data collection. Sources of out-of-tolerance investigation data should be identified within the process. There should exist a list of sources that permit collecting calibration data to identify what functions, parameters, ranges, and test points were found out of tolerance. Other information necessary to conduct the investigation is when the instrument was last known to be operating correctly, where the instrument was used during the potential duration of the out of tolerance, and how the instrument is used. When all information is collected, the impact of out of tolerance can be estimated. Investigation. Following official classification, a root cause investigation is performed. Most pharma organizations use the corrective action and preventive action, or the CAPA process, to document and implement fixes, both immediate and long-term. The process must ensure corrective and preventive actions are monitored for implementation progress and completion. CAPA is used to track progress toward preventive action implementation and serves as the means to close the discrepancy when all actions are complete. Evaluation. Some test of effectiveness must be included in the process. Usually this is expressed in terms of bad things not happening for the same reason for some period of time. This is done to make sure the corrective actions serve to reduce or halt recurring deviation. Data sources and time frame for evaluation must be established. Calibration discrepancy notification methodology defines the process for notifying affected parties when a unit under test is found out of tolerance. A compliant calibration program must include a process to let people know when an instrument doesn't pass calibration. Calibration is just the facts, not the fix. The finding means nothing in and of itself. Out of tolerance is just a classification that may trigger an investigation depending on instrument criticality classification. The finding might matter to the process owner and therefore must be communicated accurately so the impact on product can be investigated as previously discussed. The process must include the point of notification, information to be transmitted, time constraints, and notification format guidance. When notifying a customer about an out-of-tolerance finding, it is always best to have as much information available for use in the potential investigation as possible. Calibration discrepancy reverse traceability methodology ensures a process is available to identify and contain the effect of using an out-of-tolerance standard to calibrate MTE. If an instrument is found out of tolerance during a calibration, it's usually not an issue that brings up immediate questions about the MTE or calibrating standard. Usually, an investigation is performed to see if there was potential of significant effect since last time the instrument was known operable, usually the last date of calibration. The subsequent investigation, however, may have interest to the standard used for the calibration. When the standard is suspect, it peels back a layer of confidence in the calibration program. The standard of interest might have been used in a lot of places since it was calibrated to the next higher standard. Now there's a ripple effect. Now every instrument tested by this standard is suspect if it was calibrated while the standard may have been out of tolerance. If the standard is a commercial lab doing thousands of calibrations, the ripple effect could have tsunami proportions. This can be an administrative nightmare, hence the need for a process to accomplish it effectively. The process should define how the data will be selected to identify calibrations affected by the standard, since every calibration performed using the standard now must be reviewed. It is recommended that the data represented in a standard report in the CMMS or Calibration Manager software is created. Each item that has been calibrated using the out-of-tolerance standard should be evaluated to determine if the out-of-tolerance condition of the standard may have adversely affected the calibration performed using that standard. Here's the calibration discrepancy summary. The deviation program must be established to define the level of action required when deviations are discovered. When calibration test equipment is found in an out-of-tolerance condition, there's additional risk to all products on which it was used. Out-of-tolerance findings must be communicated and the effect of the out-of-tolerance evaluated. Standard reverse traceability reports are run to identify any equipment that may have been calibrated using an out-of-tolerance standard since the last time the standard was calibrated. This concludes the Calibration Discrepancy Process Descriptions presentation. Thank you for your participation.